afternoon, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 92 is on the screen. That shouldn't take you long for the measures of variation and your bell curve, yeah?
Yes, Mr. Q.
All right, good. Oh, my bad. I forgot you guys were seniors. Yes, Mr. Q. All right. So, let's let's get cracking. Should be just about done. Yes. All right. You should be done by now. Yes.
Yes, Mr. Q.
All right. So let's see. Pedro. Mean. 18.7. Hands, have you got that? All right. Okay. Variance. Pass on one. Let's see what you get. 111.06. Hands, have you got something like that? Which route did you go? Shortcut. Okay. Did anybody get something different? All right. What'd you get, Andrew? 92.56. And you went traditional? Yes. All right. So far, so good. Standard deviation. Pass them one. JC. What'd you do? Formula? I mean, shortcut or traditional? Okay. So 10 point what? 10.5. Hands, have you got that? All right. How about for traditional, win traditional, or the long way? Mia, what'd you get for the standard deviation? 9.6. Hands, have you got something like that? All right. So therefore, our average range goes anywhere from, let's see, I'm going to use the long way, this one. So we got 28.3, yes? And then we got 9.1, anywhere from 9.1 to 28.3. Hands, have you got something like that? All right. So, are we done? Tell your neighbor what's missing. All right. Range. What'd you get for the range, Patricia? What is it? 29. Hands, have you got that? All right, good. Copy the agenda, please. Warm-up number 92, and we're moving on. Today we're actually going to get into our Chapter 5, Session 1, Discrete Probability and Distributions. We're about to get, we're getting closer and closer to a couple of topics that give people problems in statistics. Get it? Problems. And, no? Yeah? You see what I'm saying? Like problems and... All right. But anyways, we're headed towards normal distribution, bell curves, and stuff like that, which we already covered a bunch of it, but we're just adding to it. And today we're just taking a step closer, and we're going to be talking about discrete probability distribution. So your home plate for tonight, for 5-1, you're going to do numbers 1 through 8 evens only. So make sure you get to that practice. And reminder, there are no late assignments for chapter 4, fourth quarter, yeah. All right, we good? So, get a Cornell note going, please. I can define and compute discrete probability distribution. Discrete probability distribution. Instead of doing a Freire model, I'm just going to break it down by terms, and I'm going to show you each term so like that you can follow along and know what each part means, and then we'll get into some examples. Okay? Discrete probability distribution. Define and compute. So, probability, once again, definition, tell your neighbor, and then we'll have Jet share. Tell your neighbor what probability is. All right, Jet, go. Thank you. Yes. And what are the three different types of probability that we've been seeing, Jet? All right. So tell your neighbor what's the difference between classical and empirical. The force. Let's go. All right. What's the difference from one to the other, Andrew? So a classical gives it an equal chance, okay? Someone's opinion, okay? How about empirical? It's given an uneven chance in regards to the actual experience of the event, that we actually do an event with whatever manipulative that we are given. So, for example, classical, if I was to ask you to give me the outcomes of rolling a die, you could actually, without having the die in front of you, just make a table. Whereas empirical, you have to roll the die and find out the chance of each of those numbers coming up. Make sense, yes? All right, so today we're going to be talking about, and I'm going to come back to what we covered towards the beginning of the school year, and I talked about what a variable was. Now, I said briefly, a variable is usually what we use in math and mathematics. We've been using it forever. Don't write this down. This is just a quick review. And we know it's a what? It's a letter, yes? And it's assigned various values. That's why it's called a variable, because it varies in value. All right. However, in probability, here goes the difference. Ready? Look up to the screen. A variable is no longer a variable. In probability, we call it a random variable. We use a letter, but because we now use probability for it, it's called a random variable. So copy this down, random variable. Random variable, a variable whose value or values are determined by chance. And for that, I'm going to use the capital letter X for today. Random variable is a variable whose values are determined by chance. And once again, why do we call it a random variable? Because we're using it in what section are we on? Probability. Anytime we use a variable in probability, now it's called a what? A random variable. All right. So, there's two types. There are discrete and continuous. And we already talked about this some time back when we started. Discrete and continuous. Discrete are basically the ones that can be given a number of possible values, or if there's an infinite number of values, then they can be enumerated or counted in a particular way. So if discrete are finite, let me repeat that again, if discrete variables or random variables are finite, ask JC what continuous variables are. Infinite. Bam. That is correct. That assume all values of the interval between two given values. Yes, so infinite amount of values. So kind of like this. Let's say I asked Samuel, since he knows everything, and I asked him to give me the temperature of the valley for today. What are the ranges? Now, I'm pretty sure he's very techy and he has like a bunch of technology. He's going to come up with degrees, but maybe up to the 100th decimal. So I'm going to ask him, so what was the degree, what was the temperature at 10 a.m. this morning, Samuel? He's going to say, oh, the temperature was 72.09 degrees, Mr. Q. All right. Well, somebody might say, well, Mr. Q, I don't have that technology. And maybe they say, like Brother says, Mr. Q, mine just says 72 degrees. Okay. So that's what we call continuous because we can give it all the different values of that measure. Whereas discrete are only enumerated for a specific time. Today, and for this section, we're going to be using just discrete. Once we move on to the next section, we'll continue with, get it? Continue with? Continuous, yes. All right, man. All right, so our objective, can you read the objective again, please? Pedro, objective. You ever hear that? No, they couldn't hear it. All right. And it's not positions, my bad. It was distributions. I forgot to change that again, my goodness. So, today, here it goes. We're moving on to discrete probability distributions. What is that, Mr. Q? It sounds really fancy. Look up really quick. Discrete probability distributions are basically, look up, a table. We've been using these, but now they have a different name because now we're going to be applying it to probabilities. All right? So, write this down, discrete probability distribution. Copy this as an example so you can have it because that's what we're going to be using for the different problems that we do today. So this, we'll just do example Michael, Jordan, Q. So discrete probability distribution, we have a table. And then the first row is going to be our outcome. And what does the X represent once again? Tell your neighbor what the X represents. Yeah, the discrete variable. Yes, very good. So, and up here we usually just write a number. A number. It's usually a whole number. A what? Whole number. However, the probability has to be in what? Tell your neighbor. Let's see if you remember. A probability is usually represented how? Very good. With a fraction or decimal. Yes. And of course, all the probabilities of X should add up to, tell your neighbor what that would be. Everyone? 1, that is correct. A quick review, yeah? You're like, a kind of, Mr. P. All right. So the sum of all the probabilities should give us 1. All right? We good? We're going to start slow on this next slide. Don't copy the problem. Copy the table that is given with the values, and then we're going to create a discrete probability distribution. All right, here we go. Example Q. Let's copy this table that they give us, and I'm going to read the problem in the meantime. I'll give you some time for that. The Baseball World Series is played by the winner of the National League and the American League. The first team to win 4 games wins the World Series. In other words, the series will consist of 4 to 7 games depending on the individual victories. The data shown consists of 40 World Series events The number of games played in each series is represented by the variable x. Find the probability P of x for each x, construct a probability distribution, and draw a graph for the data. All right, so copy that. I'll use some time. Copy and go. We good? All right, so let me go back to the previous slide to see if we understand what we're creating. We're creating a discrete probability distribution, which means the first row is going to be our what? Our what? Our x. And then the second row is going to be our what? Our probability of x. Okay, so let's do that. So, x, P of x. Okay, so what does x represent according to this problem? It says the number of games played in each series is represented by what? X. So I'm just going to write number games played. And what is our x? All of these. So on one of the series it was 4 possibles, 5 possibles, 6 possible games, and 7 possible games. Now, does everybody understand how this works? Because I sense a disturbance in the force. Okay, let's say we have Pedro's team going to the World Series and JC's team. So let's say Pedro wins the first game. And then they play the second game and Pedro wins the second game. And then they go to the next game and Pedro wins the next game. And then they go to the next one and Pedro wins the next game. So that's why it says here that possible games played would be 4 of total. Because the winner of both for the series, they need to win 4 games. 4 games. However, what if JC won the second game? Pedro won the next 2. How many more does Pedro need to win the series? 1 more. So that means if he wins another one, how many total games played? 4 and 5. So that's a total of 5 games. So possible outcomes or possible games are 4, 5, 6, and 7. Okay, so let's find the probability P of x y'all ready? So in 40 World Series, here it says there's 40 of them that have been played. How many series only played 4 games? Let's see how many only played 4 games. 8. So what would be that probability for only 4 games? 8 over 40. That is correct. So I'll write it here. 8 over 40, which translates to, let me zoom in, can we simplify this? 1 over what? 5. In decimal form, what is that? 0.20, okay. So find me the probability of the other ones, please. Talk it over to your neighbor, let them know what to do, please, if, in case they got lost. All right, help me with the next one. Eric, what do I write? 7/40 in decimal form? 0.175? Thank you. All right, help us with the next one. Andrea. .22, how'd you get that? Nice. Help her out, Presidenta. What do I write? Did you say 2, 3? How do we get that? 9/40. Hands, have you got that? So it would be .225. All right, so far so good. And our last one, Jess, what do I write? 16/40. We can reduce that to what? To what? 2/5. Be nice. Wow. 2/5 is .40. Okay. Hands, have you got that? All right. Question. Before we move on, because on the home plate it's going to come up. How can we check to see if this, pay attention to the words that I'm going to use, if this is a discrete probability distribution? Let me repeat that again. How can we tell if that is a discrete probability distribution? Tell your neighbor, talk it over to your neighbor. How can we tell this is a discrete probability distribution? All right. How can we tell? Mel. It's not infinite. That's 1. Very good. What else? Chaining. That is correct. Double check. Does it add up to 1? It doesn't? Pedro says no. Let's find out. 0.20, 0.175, 0.225, and 0.40. Let's see. 10, we got 1. 9, 10, we got 1. 4, 8, 9, 10, and we carry the 1 over. Yeah, it's 1. 1. All right, from 1 to 5, how comfortable are you with this? Yes? Okay, so what is needed? We need some data with some frequency, and then we can build our discrete probability distribution. So, I'm going to give you one that has none of this. I'm going to give you a word problem, and we're going to build our frequency and then build our discrete probability distribution. Okay? Here we go. Copy this one, example number 1. Copy the problem as it reads. And it reads, construct a probability distribution for rolling a single die. Rolling a single die. One single die. Be nice. All right. Let's see. I think Pedro's got it. What do I write on top? Oh my goodness. Nice. Okay. Okay, thank you. And what's the probability of each of those? Like I said, we already did this. Now we're giving it a name. Some of these we've already done. Tell your neighbor why this is a discrete probability distribution. So question, does it add up to 1? Oh, okay. So JC's saying that if we do decimal, it's not going to be exact. So for this one, to keep it exact, we're going to leave it as fraction, okay? From 1 to 5, how comfortable are you with distributive, discrete probability? 10s, all right, 10s and 5s. All right, let's crank it up a little bit, yes? Oh, yes, copy this one. Example number 2. Write that down, please. It reads, construct your probability distribution for the sample space for tossing 3 coins and getting heads. Oh, okay. Now this one, I think we're going to have to do a list of those to kind of like have the frequency and then build our distribution. So let me get you started. Coin 1, coin 2, coin 3. All right, so first let's list all the outcomes. Get us started with the first one, please. Andrew. Bam. Continue, Mel. Very good. Continue, chain A. Yeah, let's go. Continue, Vince. Yes, I do. Continue, Amy. All right, let me go to the other side. Matthew, go. THT, okay. What else? Jet. THH, okay. And are we missing anything? So, neighbor, which one are we missing? All right, Patricia, which one are we missing? Yes, TTH. Do we have all these possibilities? Yes? Okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Huh? All right, let me show some numbers just in case, just to check. What are the possibilities for one coin? Well, 2 of them times 2 of them times 2 of them. What is 2 times 2 times 2? 8. Yes, okay. All right, so what are they asking us? Of getting heads. Okay, so let's write our discrete distribution. Numbers of getting heads. Okay? And this is P of X. So before we use this, question. What are the possibilities of getting heads? What do we start with? Is there such a thing of not getting any heads? All right, so 0. Is there a possibility of getting one of them heads? Yes. How about 2 of them? 2 of them? 3 of them? Anything else? No, because it's top 3, right? All right, so we'll stop right there. All right, so let's see. Talk to the neighbor, let them know what you're going to write here to get started. All right, Patricia, pass someone. Yes, Amy, what do I write here? What is the possibility of getting 0 coins with heads? 1 out of what? That is correct. Bam! All right. Next, what is the probability of getting at least 1 combination that has 1 head? At least 1 head. Check it out with your neighbor. Only 1 head. Let's see, in case you don't see it. 1 head, let's see, no, this one has 3, 2, 2. Here's 1, 2, and 3. So what do we write, everyone? 3 out of 8. That is correct. All right. Fill in the other 2, please, and then double check to make sure it is a discrete probability distribution. All right, Pedro, go. Pedro, go. 3 out of. Thank you. And Don, the last one. Are you asking me? Oh. Hands, have you got that? That is correct. And let's check to see if it's a discrete distribution. Is that equal to 1? That is correct. All right. Now, in the home plate, they might ask you to make a graph. So the graph would look something like this. This is our x. This would be our what? Yeah, our P of x. So then what is our x? We start at 0, 1, 2, 3. And then we have 1/8, 2/8, 3/8, and so on and so forth, and then just show, bless you, just show, oh, this is 1/8, sorry. You can show it with a bar, like so. And there it is. That's a simple graph. All right, from 1 to 5, I'll come to borrow you with this. Yeah, we got it, right? Yeah? I'll stop right there. Once again, your home plate for tonight. Make sure you go to the last section of this, look for the exercises, and do numbers 1 through 8, evens only. I'll stop the video right there. Enjoy. Bye.